Hello everyone, and today we're taking a look at the very cool flow along surface commands that we have in Grasshopper, and with that as well the repetitions and very smooth kind of interactivity to it, as well as some other features that we have, for example with the base height and base things. Furthermore, we're taking a look at this with two different scenarios of how we can actually apply this. I will run through the first one and then we go to the second one. So let's do this. Okay, perfect. So we're going through a complete new file. So let's first of all start with an empty file. And if we go into the geometry, we have our geometry that we want to apply to, which would be this one. And then the surface that we want to apply it to, that we can, if we use points on, we can still modify and change. Okay, so first of all, let's import those two geometries. Just by geometry, right click it, set geometry, click it, and we will just put another geometry thing here, right click, set multiple geometries, and then we just select those things and click enter. So they're already like now in the Grasshopper environment, which is very, very good. And I now want to show you how was the thought process of getting those things on there. So basically, we have our surface, right, which has some kind of shape, and then we also have our geometry that will be basically placed on this thing like here, and has a certain shape to it. And then we want this geometry to be basically passed on to the next one, then to the next one as well, to the next one as well. And not only in this direction, but only into that direction. So what we need by that is also knowing the surface length or the dimension from here to here. So what is this one? And we also need to know the dimension of this piece over here, which you would go through as well. Okay, so how are we going to do this? This is actually not that difficult. So there is a command which is called flow along surface, or flow along. Let me actually take a look. No, it's not this. It's under transform morph, and then it's surface morph. This one here. And this will be basically our final geometry outcome, and it takes several things. First of all, it takes the geometry, it takes the reference from where we have the geometry from, then the surface we want to project onto, so this one here, and then the U and the V domain, which is basically this part here and that other part here. And the W domain is basically the one that goes into the Z direction, so basically up into to make it three-dimensional. Okay, so we have to basically now first create the reference box here of this one. So we just do a bounding box like this, and we obviously need to put it on the correct one, and then you see it does those for all three, but we want to have it surrounded by all of them. So we just right click it and then click union box. Now it will create it through all the things around like here. Okay, this is already our reference box, and then the geometry has to be this one here, but we actually want to make it into a mesh and join this mesh together, so it will be just a combined surface for all of those things together. Now we have our geometry. However, now the question is, okay, you want to have it on the U domain and the V domain, so you basically want to have it like chipped along like those pieces here. And we're going to do this by creating a range, and then this range has a certain amount of steps, and we want to have it so that if you put this in right now here, you see it will give us always the domains of 0 to something, 0 to blah blah, until 0 to 1. What we wanted to have it so it's a 0 to 1, and then 0 to 9, 009 to 0.18, then 0.18 to 0.27. So we're going to do this by simply shifting the list, and we are shifting it by 1, and then we're going to construct a domain. And this domain will be then the starting points would be this one, and the endpoints will be that one. And we also not want this to wrap, so basically like go from like start to finish. So and we also might need to exclude one point, and I think I will actually exclude the first point, so cool index, and we just removed the first point here. So now it should look quite fine. At least like the endpoint is kind of bothering me. In this case, maybe we can just reverse this one here. Anyway, I think we will just go for this one for now. It might be fine to have it like that. And now we put those domains in here, and nothing happens yet because we still need the v domain. And this one we just gonna copy. This one here, as well as the number slider for the amount of steps, and we put the v domain in here as well, and then we have to have one final one for the w domain. Now we also need to connect the surface as well here in the end, and you see it actually kind of creates a little bit here something in the beginning. So because we use the domain to 0 till 1, we actually have to reparameterize this curve, and this is very easy to do. We just right click this one here and click reparameterize. And as you see, the result is still not exactly what we're looking for. That's because we need to graph the u or the v domain. And if we just graph it, you see we have this surface now applied correctly. So that's pretty good. And I want to increase this number slider as well down here, so we have a little more v direction as well. So yeah, here we already have your first result, which is very easy to do, obviously. This one is red because there are values of 0 in the v domain or in the u domain, and it cannot really cope with that. So this throws an error. However, the geometry is still fine that gets put on here. Okay, good. So this one works perfectly, and we can just obviously move it in the x and the y direction, and we can obviously bake our geometry how we want to bake it. So now, even though this already works fine, I want to show you a different approach of how you can still use applying it, how you can still apply this surface that we have here, but we use it in a different way, like in different matter of using it or approaching the problem. So let's just disable this one here for now. And what we're going to do this in the other approach, we're gonna first duplicate the points that we have here on the ground into the x and the y direction, and then we're just gonna put those on here, and we simply have the surface basically relooking at each of the elements and then just applying it on there instead of applying them directly. So we're gonna do this by first we have to evaluate this box further. So we have to deconstruct box, and we're gonna deconstruct the box that we created here in the beginning, and then we need to because we basically want to make, just draw this out, we want to have them just spaced out evenly like this, and we basically need to know like by how much we need to space them out. So we're just going to deconstruct this box and define the maximum amounts of this box, and then we're gonna move it by x direction and by y direction along to it. So we're gonna just deconstruct, because it gives us here a y domain and an x domain, and we're just gonna deconstruct the domain of it like this here. Or actually, there was still something I want to put in here so you can see it better. Okay, you can ignore that. And we're also gonna deconstruct the other domain as well. So now we have those two domains, but they might be negative, as you see, because it might be in the negative direction or in the negative area. So we're going to use absolute, which basically makes this those things positive, regardless like if they're negative or not. And we're going to use this with the other one as well, and then we're going to add those values together. like this and like that. Good. Now we have our basic sizes of that one, and we want to now move it, and we want to move it by the steps of this amount. And we're gonna just use a series, and the count will be the amount of how many duplications we want to have for that. Like that. And this will be then the vector of how we want to move it. So we just construct a vector for that, like the moving vector. And we can just put those two things, hopefully they're the right way, right? Yeah, X, Y, yeah. And this will be then our moving pattern. And the moved objects will be our meshes that we created here in the beginning. As you see, it will just create them one by one because we need to actually graft the Y component of our thing as well. And as you see, it creates a perfect one by one copy of each of our things that are now on the ground. Like they're going one on top of each other, and obviously if we change those things around, it would still be applicable to it. The great thing now is we have those things created now, and we want to create a bounding box surrounding that as well. Bounding box. I cannot write, as you see. There it was, but I missed it. Bounding box here. And we want to not have them each individually be bounding, but we want to have them all. So we want to flatten this tree and then make a union box as well. So now we have this gigantic box surrounding it. Just gonna hide this really quickly, this box, and we want to apply this box now to that part. And this is actually quite easy. So we're just gonna copy this one, and actually let me just take it completely from scratch here. So the surface that we have here is the surface that we defined already in the beginning, this one, and the geometry is the one that we defined here while we moved those things. The reference will be the box that we created here, and the U and the V domain would actually, if we reparameterize it, be just one. So we can just put this in there. And for good measures, we take the same one that we had here in the top. And you see it already created our things on the thing. And the great thing now is, obviously, if you would need to do it in Rhino, you'll have to reapply it every time and redo it every time. But here we can just, obviously, we have the thing and we just change it around to our needs. And it's completely fine if we change any of the parameters that we had here. So you can change obviously the box around here like that, or we want to move it around or like rotate it a little bit, and it change accordingly. And obviously in the end you can always make a custom preview like this and give it a color picker. No, not that one, sorry, this one here. And we have to flatten that one here to use the correct color. And if you go into the preview or the rendered view, it will give us this very nice shape. So yeah, thank you very much for watching. Like, this is basically the whole approach to it and how you can have those in the different two kind of ways. So one time just applying it directly, and the other one making some changes first in the beginning and then applying it. And I think it's actually a bit lightweight. It's a little more easier to process. So if you have more bigger construction things, this is the way to go for this example. So yeah, thank you very much for watching. Hope to see you in the next one. Subscribe, do all those kind of things. And yeah, tell me if you want to see something, let me know, and see you in the next one.